So welcome back for this third and final video in this series. This is Theorem 13, which is the last of the ratio proofs that you are required to know and be able to reproduce in the Leaving Cert higher level exam. So I'll share a study tip at the end of this video, so make sure you watch till the end. So Theorem 13 states, if two triangles ABC and A prime, B prime, C prime, if those two triangles are similar, then their sides are proportional in order AB over A prime, B prime is equal to BC over B prime C prime is equal to CA over C prime A prime. So what do we mean by similar? Similar triangles have got equal angles. Basically, one is an enlargement of the other. That's what we're trying to prove, that their lengths are proportional. Because they're similar, we know that the angles are equal. The angle at A is equal to the angle at A prime, and so on. We're trying to prove that each of the lengths are enlarged in the same proportion. So for example, AB might be double A prime B prime, and if it is, then BC will be double B prime C prime, and so on. The same structure of diagram given to prove construction proof must be kept in every single one of these proofs. It is required. Sometimes in the exam they will give you a template with these headings written, sometimes they won't. Sometimes they will give you the diagram, sometimes they won't, and you'll have to draw it yourself. These headings are required, and remember, every line that I have written in this proof is important. You shouldn't try to summarize it or write it in your own words. The words that I'm giving you in these proofs are the exact words that are guaranteed to get you full marks on the exam. So it's 15 marks. Let's not mess around with this. So what we are given is that we've got the similar triangles ABC and A prime, B prime, C prime that you can see in the diagram. And as we said, in similar triangles, we know that the angles are equal. So the angle at A is equal to the angle at A prime. The angle at B is equal to the angle at B prime, and the angles at C and C prime are also equal. So what are we trying to prove? We are trying to prove what we're given in the original statement here, and they will write this part here. So basically your bit to prove is just to rewrite that length of AB over length of A prime B prime is equal to the length of BC over the length of B prime C prime, etc. Okay, remember these vertical lines, these modulus bars, they represent length in this case. So our construction says we want to mark B prime prime on AB so that its length is the same as this length, A prime B prime. So I'm going to put it here. Now you don't have to measure this with a ruler, but it should look fairly accurate. So mark B double prime such that A B double prime is equal to A prime B prime. Okay, got it. The next thing I've got to do is mark C double prime on AC such that the length from A to C double prime is equal to A prime C prime. So I think it's going to be about here. Call that C prime prime. Here is what then my diagram will look like. Don't worry about those little marks in the angles, they'll become clear shortly. And then the last step is to join B double prime to C double prime, so that's that horizontal line there. So on to the proof. We know that A, B double prime, C double prime is congruent to A prime, B prime, C prime. So we know that these two triangles are congruent. Congruent means identical. And why are they congruent? They're congruent due to the SAS, side angle side congruency condition, and that's from the information given and in the construction. Now I'll go through that with you briefly, but explaining congruency is not really the purpose of this video, so you might need to go back to your textbook if you need a bit more help on that. But they are identical because of SAS. So let's see what information was in the given and the construction steps that tell us that. So SAS, we know that in the given steps, our angles are all equal. Okay, so that's fine. The angles are all equal. In the construction step, we know that that length is equal to that length. That's the first line of the construction step. We also know that this length is equal to this length. That's another pair of lengths that are equal. And the given step told us that all the angles are equal. So the angles at A and A prime must be equal. So I've got S, A, S, S, A, S. I've got the side angle side condition for congruency fulfilled. We've got two sides and the included angle that are equal on both of those triangles. Now remember, we're talking about A, B double prime, C double prime, A, not the bigger triangle there. Okay, so that's the first step. We have stated that they're congruent. You'll see the notation we're using for triangle, and we've given the reason in the bracket afterwards. You must always give a reason. Remember I said that all of the words on the screen are all important. So side angle side from the information given and the construction. So we know that this smaller triangle here on top is congruent to this triangle here. That means they are identical. If they're identical, all of their lengths are the same and all of their angles are the same. But just don't get confused. Earlier we said the angles of the big triangle are equal to the angles of the small triangle because they're similar. Now we've shown that this triangle is congruent to this triangle, which means that their angles are also equal and also their lengths are equal. So I've got that AB double prime C double prime is equal to AB prime C prime. The two angles I've marked with a dot are equal because the two triangles, the smaller triangle on top and this triangle, are congruent, so those angles must be equal. We also know that AB double prime C double prime, so that's this angle again here, is equal to ABC, so that's the angle I've marked with an X. Now, we also know that those two angles are equal, and they must be equal because remember we said at the beginning that A prime, B prime, C prime, and ABC are similar. So we know the angles in these two are all equal. Now we know that this pair of angles are equal, so therefore these two guys must also be equal. So AB double prime C double prime is equal to ABC. That's the two angles I've marked here in blue on the diagram. So now we know they're true. So then the next step is to say that if those two angles that I've marked in blue are equal and they're sitting on these two lines, then they must be corresponding angles. And if they're equal and they're sitting on these two lines and they're corresponding angles, well, corresponding angles happen in parallel lines. So it tells us that these two lines must be parallel. So if they're parallel, we can go back to Theorem 12, where we said that a line parallel to the base of the triangle will cut the other two sides in equal ratio. Then we know that this length here divided by this length here is going to be this length divided by this length. And again, you don't need to reprove Theorem 12 here. Once we get on to a higher number of proofs, so on Theorem number 13, we assume Theorem 12 to be true and we can use it in our proof. So we can just say that from Theorem 12, we know that they are in the same proportion. So nearly there now, this is a long one. So we've said that AB over AB double prime is equal to AC over AC double prime. But we said earlier that AB double prime is equal to A prime B prime. Where did we say that? AB double prime is equal to A prime B prime. So therefore, I can replace AB double prime in this step with A prime B prime. And likewise, I can replace AC double prime with A prime C prime because we said they were equal over here. We could repeat the process, but we don't need to for the purpose of this proof. But you could draw a parallel line in the other direction and say that BC over B prime C prime is equal to AB over A prime B prime. And so put all those three together and you're back again to the thing you're asked to prove. The length of AB over A prime B prime is equal to the length of BC over B prime C prime is equal to the length of CA over C prime A prime. Okay. That one is a lot, I think, but lots and lots of practice and you will be able to memorize these steps. Right, I promised you a study tip at the end of this. My study tip for these theorems is they're a lot to memorize, but it doesn't matter whether you're going for a top grade or just trying to get over the line. If you're in higher level maths, you have shown in the past that you are able to memorize stuff. So this is a question that you should be prioritizing because if it comes up, and it nearly always does, it's guaranteed marks. So what was the study tip I was talking about? The study tip is when you're learning these theorems, I would suggest the first time you learn them, you put the time in and you memorize them. Now, yes, I know you're going to forget those again before the exam, but the way that your brain works is every time you learn something new, connections form in your brain. As you were watching this video and this explanation and making sense of it, connections were forming in your brain. There's little gaps between the synapses in your brain, and there was little electrical currents flying between them and chemicals passing between them, creating these neural pathways that get stronger every time we revisit a topic. So I would suggest you memorize this now, even though you know you're going to forget it before the exam. But it means that when you come back to memorize it again, all you'll be doing is revisiting those connections that were formed in your brain in the past and strengthening them. So if you memorize these properly now and then set a reminder on your calendar to come back to them, let's say every month, once a month, and just do a quick revisit every month. By the time it comes to the Leaving Cert then, this will be a last minute thing 2 days before your paper 2 exam, where you just Practice these a couple of times and it should be so easy. If you're trying to sit down and memorize these for the first time in the couple of days before your exam, it's probably going to take you a few hours. You'd be better off spending those few hours on other things. So my advice is memorize them now, revisit them regularly, set alerts on your calendar to remind you to revisit them. It should only take 10 minutes to revisit them every month, and it'll save you a few hours at the end of the course when you really need the time for other things. All right, I hope that was useful. Please make sure that you share my Instagram and my contact details with anybody who you think will benefit from any of the other courses that I have available. You can see everything that's happening on my Instagram and on my website, www.themathsexamsexpert.com. Thank you for watching.